You've found Find Your Flock, Season 2. I'm Dr. Sandra Clavijo. Join me as we hear how students turn curiosity into careers that make an impact. Today's guests are alumni from our physics department. Please welcome Michael and Jordan. Hi.
Hello.
Hi.
Nice to see you guys. How are you doing?
Yeah, we're good. How are you doing today?
Good. Coming all the way here from Michigan, so we love that. Do you each want to introduce yourself a little bit and tell us what you studied at Stevens?
Sure.
Sure. I am Michael Gajdosik. I did a physics math double major at Stevens and I graduated in 2023. I'm now a PhD student in theoretical nuclear physics at Michigan State University.
Excellent.
And I'm Jordan Cory. I also did a physics and math double major at Stevens, and I also graduated in 2023. And I'm also at Michigan State University, but I'm doing my PhD in experimental nuclear chemistry.
Excellent. So I didn't realize you both had double majors in math. When you do you primarily identify with the math major or the physics major? Tell us what first drew you to study physics and math at Stevens.
Yeah, I think we both came in just as physics majors. So I would say that's what we more primarily identify with, and we do work, even though I'm a nuclear chemist, my work is more physics oriented. So I would say we both do a lot more physics now as well. But the math degree was very useful and very helpful in its own right while we were at Stevens as well.
Yeah, and I would say on the theoretical side, I definitely identify with physics first, but the math is very useful in a lot of ways for some of the classes that I took, and I'm actually dual degreeing my PhD with computational math, so the math tool is very helpful, especially there. So it was a really great experience, and I think like the classes were taught very well and prepared us pretty well for the graduate classes that we've taken in the last couple of years.
So our podcast is trying to help students, understand their different major choices and be really comfortable with their selections. But what I'm hearing from you guys is you can do both and
Mhm.
all of your interests, which is also like really great. So was there like a particular course, professor, or a project that kind of inspired your journey while you were at Stevens? Like any come to mind?
Oh, a ton. I mean, Jan in the math department taught our proofs and refutations class, and I thought he did such an incredible job. And it was the like s spring of 2021, so it was still like right in the middle of COVID. Um, but he did such a great job, and that really cemented like why I wanted to do the double major in the first place. And I still think back to a lot of my interactions with him and uh, throughout the years at Stevens that have shaped my career to some extent.
Yeah, I would also say, so our freshman year is when the pandemic first happened and everything got really shut down. So we were both originally planning to try and do some physics research the summer after our freshman year. But, you know, that kind of all went awry. And we actually both ended up working with Professor Wellerstein in the humanities department. And he studies nuclear history. And we were like transcribing primary sources for him. And it was very interesting work. And that was really what inspired me, at least, to want to start looking into nuclear science as well. Because it's such like a rich field between the history and the science aspects. So that kind of started my journey, and that's what made me want to start looking into physics internships the following summers that focus more on nuclear science and led to where I am today.
That's amazing. I know you both had a lot of great summer research experiences, and you were able to participate in a research experience for undergraduates, which is an REU. For those who don't know the term, we say REUs a lot, but it's research experiences for undergraduates. I mean, Jordan, like you got to go to Switzerland, so I mean
Yeah.
that one's pretty amazing. Texas is cool too. I know you guys got to do, a fair amount of them. But if you want to tell us a little bit about what a research experience is for undergrads and then the opportunities that you were able to take advantage of.
Yeah, Jordan got two of them, so we should say how you did that first of all.
um, Yeah, I mean, a research experience for undergrad, you basically, as an undergrad, get to join a graduate research group at a university. So my first one, I was at Lehigh University in Bethlehem, Pennsylvania, and it was a really great experience. They taught me a lot, basically all of the foundations I know for coding. And every day I just got to like go in the lab, work with the graduate students, work with the professors there, and really learn a lot. And through that experience is how I made connections that allowed me to get my second REU, which was through the University of Michigan, which sent me to CERN. So this one is a little unique because instead of working at the university that was sponsoring me, they sent us to this lab and we were working in this lab group at CERN. So instead of being at University of Michigan, I was working with graduate students from all over the world. There's also a big program for undergraduates at CERN, of which the United States was a small part of through the University of Michigan. So you get to meet all these other students from all across Europe, and we got to spend a lot of time both in the lab and working on my coding experience. And those are also the people that gave me a lot of input and guidance in applying to graduate school and leading to where I am here. But I would say definitely one of the most important things is starting to try to apply to these experiences as early as you can, because it was my very first experience at an REU that led me to my second one, that led me to my current place in grad school. So everything really builds on each other, and it's really valuable to start as early as you can.
That's amazing. But like Michael, you had some too. Let's hear about
Yeah,
your
yeah. I did an REU at Texas A&M. I did work in theoretical physics. This was the summer before our senior year. Um, and my advisor there is a really great guy. He, I think, is retired now, but he did his PhD at Michigan State. So I went and I had a nice time, and the Cyclotron Institute was spectacular where I was working, but I kind of Texas wasn't really for me in terms of grad school. But his recommendation letter, I'm convinced, is why I got into my program here. And so it kind of has that snowball effect. But there were just a lot of great experiences to be gained, and getting a taste of what academic research is like was really important for shaping my like opinion on whether or not grad school was the right choice for me. It's really hard to know exactly what goes on in an academic institution like that versus in industry without having some like experience in that realm. And it doesn't need to be an REU. There are other ways to get that, but an REU is an excellent opportunity.
Yeah, definitely. REUs can take you to, try out different schools. We do a fair amount of research on our own campus, but it's nice to be able to have the different kind of rotating experiences and see, you know, the what those other places look like. And, sometimes it's good to cross them off the list if Texas is off the list, right?
Right, right, right.
You can start eliminating, not apply to so many schools. So awesome. So your current work, you're both at Michigan now, Michigan State. Are you in
Mhm.
the same lab or are you in a separate lab? Who's in
We're in very separate labs.
Okay.
Yeah,
Same
Perfect.
same
building.
building.
Okay. Perfect. And that facility is that the rare isotope beams building? I know we have a photo of that somewhere. But so yeah, tell us a little bit about your current work and your research focus at Michigan. Our audience may be not super technical, so anything you could do to simplify your work. But yeah, I'd love to hear about your current work and research focus.
Yeah.
Yeah.
Okay. Yeah, I do theoretical nuclear structure physics, and so that is really starting with treating nuclei as just a clump of protons and neutrons. Um, and you have all of these quantum effects and all of these interactions that make the problem really hard to study. And so if you're interested in things like the half-life of a radioactive nucleus or certain properties like how it emits gamma rays or like uh, beta decay and like different energies that are associated with how those protons and neutrons form in the nucleus, you need to run like really intense computations. And so we have very good theory for lower mass nuclei, like through oxygen and even calcium. Um, But then as you get heavier and heavier, the problem grows in computational cost. And so even on the world's largest supercomputers, you wouldn't be able to compute something as heavy as radium with the like quote unquote exact methods that we would want to use. So my job is really to study all of these nuclear properties using methods that are quasi-exact. And so we make like educated truncations that allow us to compute heavy nuclei. And so we can get some of these properties and hopefully be accurate and then compare with experiment and vice versa and test our theories while also informing experiment. And so that's kind of like the middle ground that I sit at where I talk to a lot of theorists that are a bit more fundamental, and uh, they're pretty out of touch. And so I take what they do and I try to make it reasonable to predict what an experiment would see, because those two worlds are very separated.
Excellent. That's so interesting. I can see where your math background comes in super handy here.
Quite a bit,
For
yes.
sure.
So my work is much more on the experimental side. So primarily what I was doing for a lot of the beginning of my graduate degree was developing a detector. So we have a lot of collaborators, one of which is at Indiana University. So I was helping build on an addition to a detector that they already have. And now that we're starting to wrap that up, we're heading into the next phase where we're planning to run an experiment soon. And the goal of that experiment is to measure basically the rate at which these certain isotopes will fuse together and make a compound nucleus. And the primary goal of this is to apply this to an astrophysical context. So the more like astrophysics jargon would be like we're looking to constrain certain reactions that are in type 1 X-ray bursts. And those occur when you have a neutron star and a low mass companion star, and the companion star accretes its matter onto the neutron star. And you'll have all these nuclear reactions happening. So it's really cool because there's a lot of different contexts and a lot of different type of work I get to do because you get to be in the lab, building detectors, testing things. You also get to run your experiment, and there's also a lot of coding involved, doing the data analysis. But then there also is getting to learn all about the astrophysics and the ways your research could be applied to different contexts. So it's a very versatile project, and I think that's what makes it really fun for me.
Definitely. So math, physics, chemistry, astrophysics, always staying curious and learning, is what it sounds like to me. So I know a lot of students when they're coming in, and they're thinking about different majors and thinking about, what pathways exist for physics. You two are great examples of a research kind of pathway. Are you guys familiar with any of the other pathways for physics students that you maybe learned about through your studies? It's a very broad field. I almost think like what can't you do with a physics degree sometimes because it is so broad.
Yeah.
But
Yeah.
yeah, any other pathways and different kind of industries that are always scooping up physics majors?
Yeah, absolutely. I would say we have a lot of friends that have gone into just all over the place. I mean, there's a couple people we know with physics degrees that work on Wall Street. There's a few people that go into defense and like more engineering oriented jobs,
Mm-hmm.
or um, even like some in medical technologies, although those usually require more advanced degree. Um, where with a bachelor's in physics, you can go into like most engineering things. What I always like to say is physics will qualify you on paper for basically anything, but the physical preparation usually means that there's more of a learning curve when you get to the job. And so that's something that you kind of need to be aware of. So like staying in field, there's not as much of a learning curve, but if you go into Wall Street, you're going to need to learn a lot very quickly compared to someone who did like a finance degree. That being said, I think you have the skills and you have the problem solving, but there's just like a lot to know. Like there's a lot of terminology and things that take a minute to get up to speed.
Yeah, I would say the great thing about a physics degree and a math degree as well is that it really teaches you how to think about problems and approach them critically. So even when it's something that you're not maybe specifically trained in, you have the skill set to figure out what actions need to be taken, and it gets you very comfortable with learning how to learn and always being able to be willing to tackle the next problem. which is really valuable in whatever you decide to do with your degree.
That's amazing. Um, so what's up next for the two of you? I mean, when are we planning to finish? Are we staying in research? Are we hoping to be professors? What are we thinking?
I think graduate school is typically around a 5-year degree. So we are in our 3rd year right now. So maybe about 2.5 years left until we graduate. Um, I think for the next step, we would both like to do postdocs in the short term, which would just be continuing to do research in a similar field. Long term, yeah, it really just depends. I'm open to a lot of things. I think one thing that's led me to where I am has been being open to a number of possibilities and just trying a lot of things out and seeing what I like and what I don't like. So if I like the research that I'm doing and there continues being doors open for me, I can definitely see myself pursuing that path, but I could also see myself maybe pivoting towards more medical physics or a different type of industry job. Um, yeah, it all just depends where everything's at in a few years.
Yeah, and I think I'm in a similar boat. I definitely want to be a professor as my primary aim. So I would need a 2 to 4 years of postdoctoral research, which are usually like pretty decently paid positions. It's sort of like a professor in training a lot of the time. But one caveat I will mention is every grad student you talk to when they start says that they want to be a professor one day, and then every fifth or sixth year grad student that's about to defend is doing anything but that. Um, and so I do think that there's a like a feed out problem that goes on. I mean, there's so few professor positions compared to grad students graduating. So ask again in 2 years and we'll see.
I love that.
That's the goal.
I love that you guys don't have it figured out. And I think that's such a great message for students. Jordan, you would describe something called like following the flow, right? If this is interesting, the opportunity's there. Like, sometimes we think when we open a door, we're closing other doors, but you're actually just opening a new set of doors,
Yeah.
right? And then you just get to continuously walk through these new doors. And then like the new opportunities are there that you didn't even know existed before. And that's such like maybe an overwhelming thing for a 16-year-old who's choosing majors, but
Yeah.
as you're going through the curriculum, if you like the courses or you like the research or you like the professor, do something you like, right?
Hmm.
Yeah,
Yeah.
It can be like just much easier than like, oh, there's only one path to get to, physics professor or one path to get to whatever. So I love that.
right.
So fun. So all right. I always like to end these with pitching. I know we love innovation at Stevens, but we make students pitch sometimes. So why should someone choose to start their degree at Stevens in physics and math?
I'm taking this
Yeah.
one. Okay. You should start your degree in physics and math because it gives you a tool set, it gives you a mentality that will prepare you for genuine real world experiences. There, people hire physics majors specifically for a variety of different jobs, and it's because that mindset, that like problem solving ability that you learn is not just applicable to like rolling a ball down a hill or studying quantum mechanics. It's applicable everywhere. These patterns are everywhere in the world, and you get to study a degree that just shows you how things work in general. And so if you want to do random things and you want to have some flexibility in what you do by the time you're graduating, by the time you're 5 years into your career, a physics degree is great for you. A math degree is also spectacular, and I think that they support each other very well.
I
Yeah,
love
and I would say, having done, all of our physics classes at Stevens throughout undergrad, um, I just felt very prepared. I feel like the teaching here is excellent. I don't have, um, there's like no limit of good things I could say about all the professors we had throughout our undergrad. And they really prepared us and taught us very well, for whatever we decided to do next. And I think that has been really borne out here at MSU. Starting our graduate classes, they were not in any way too challenging because of all of the preparation that we had received in our undergrad. So I think this is a school that will really prepare you well, teach you well, and also has a lot of resources to help you find these internships, try to apply to jobs, or support you in wherever you want your career to take you, whether that be graduate school or something else.
If I may add, I think the physics courses at Stevens are taught exemplary well, like beyond what I can describe. We are at the #1 nuclear physics PhD program in the country. And when I tell you that Stevens teaches their physics courses well, I mean, they prepared us
Mhm.
way
Very
beyond
well.
what I could describe. It's we came in and the courses here are like, oh, this is fine.
And there's not even, a nuclear physics subset at Stevens, but, you know, just the foundations were so good that we could really take it anywhere we wanted.
Yeah,
That's amazing. I feel like Ting Lu's heart's gonna break when she hears that.
Yeah.
absolutely.
She's the one who recommended you guys to come on. But yeah, that's amazing. I love working with the physics department. It's just there's an amazing collection of faculty and staff members that, really work hard on the program. And, they also have to do the service classes for all the engineering students too. But it's really a wonderful, nice, tight-knit community over there too. Um, Awesome. Well, that is all the time that we have for today. I'm so thankful that Jordan and Michael could come join us from MSU and kind of give us a peek of what's been going on the last couple of years. And we can't wait to see what's next for you. It could be something that we didn't even talk about today, which is,
Yeah,
I think, the beauty of physics. So thank you for joining so much, and please feel free to check out our other episodes. Have a good day.
thanks so much.
You've been listening to Find Your Flock, Season 2. I'm Dr. Sandra Clavijo. Thanks for joining us as we help future ducks find their path at Stevens. Don't forget to follow and subscribe on Spotify, Apple Podcasts, or YouTube, and share this episode with a future duck.